Hello guys, today I will present to you lab E2 part 1 Charlieplex LEDs. 3 inputs D4, D5, D6, 3 outputs A4, A13, A5, and then let's go to the code. First, what I do is I call the function initialize Charlieplexing, which are declaring ports. Then for loop, infinite for loop, get input from user, add the switch to set which LED you want to light up, and then delay the function so that the user can see it. Okay, let's first go to initialize Charlieplexing. Okay, initialize Charlieplexing. I link the clock to port A and port D to use it for some reason, and then port 4, 5, 13 as an output. Actually, you don't need these two because this one are more for inputs, and DSEMAS is to get it to be able to have high drive strength. And then 4, 5, 6, max 1, equip it to be an input, to be allowed to be an input, pull enable, and then pull up or pull down. Then going to the next one. For our circuit, we are using a pull up in the sense that when this input is not connected to any active devices, it will have a logic high from the VCC, as you can see. Logic high VCC, when switch is open, its voltage is pulled up to VCC. Okay, moving on. Output 1, output 2, output 3. This one is declaring them an output. I predefined them up there. 1, 2, 3 here. Port 4, 13, 5. And then input 4, 5, 6. Okay, scrolling down. This one is basically saying port D and port 1 and the complement of port 1, the output. This one is declaring as an input because port D will receive a value of 1. Input 1, which is a 1 up here, complement it will become 0, so the PDDR will be 0, so this part PDDR will always be equal to 0, which is an input. Okay, moving on, here is void set LED function. The input is LED number, so basically if none LEDs are on, all the outputs are set as input high impedance, and then this one is declaring them as input only. Okay, so let's say you want LED number 1 to be light up, this D1 here to be light up. Basically what you do is port 4 and port 5, port 4 and port 5 are equipped with high drive strength, which is this one, port 4, port 5, high drive strength for D1. You want your A4 to have high voltage, here to have low voltage, which is written here. Set output 1, which is A4 as high, A4 high. Output 3 as low, clear it lah. So low, so that the voltage drop across D1. And here you set output 2 as high impedance, so that there will be no current going into here. All the current go through here. Then basically, okay, let's give another example, LED num 2. So if you want D2 be light up, A5 must be high, A4 must be low, A13 must be high impedance. So as you can see, output 1 is low, clear it. Output 3 is high, you set the output as 1, and then here high impedance. And also you don't equip the one with high impedance with a high drive strength. You can choose to, I think, but you don't need to. Then basically for the other LED numbers that you want, you just, according to the truth table that you can set like this, you want which one on, then which one you set it as high impedance or low. Oops, I stopped the video for a while. Okay, moving to the read input. Okay, here is basically saying for each output, right? Each output here, I'm shifting the bits 4 times to the right because I want, at first it's like 2 power 6, 2 power 5, 2 power 4. I want to make it more readable and easier to compare later on. So I make it 2 power 2, 2 power 1, 2 power 0. So here I'm saying a port D and the and the 6-bit value, when both of them are 1, that will give me a 1. But so it will depend on input 1 because I think that this one is always a 1. So basically this one 2 power 6 port, which is D6, will be moved 4 times to the right, which will become 2 power 2, 2 power 1, 2 power 0. And then I combine them with the OR sign. So 2 power 2, 2 power 1, 2 power 0. And then these values are compared with its int and is stored in variable D. So later on, so right now D has 2 power 2, 2 power 1, 2 power 0, and the maximum number of LEDs we have here 1, 2, 3, 4, 5, 6, and then my logic also like from 0 to 6 LEDs. If the value of this is equal to the for loop's value, return an E value, else return 0. That means that when I receive an input of more than 7 here, 1, 2, 3, it will return 0 to be used to return no LEDs on. And now I shall show you the switches. Okay, let's continue. So we have 6 LEDs, D1, D2, 3, D4, D5, D6, and 3 inputs here. 1, 2, 3. So this is D1, D2, D3, D3, D4, 5, D6. Okay, let's start. 0, 0, 0, 0, 0, 1. First LED lights up. 0, 1, 0. 0, 1, 0. 0, 1, 1. Okay, and what is that? 1, 0, 0. Fourth LED, 0, 1, 0. 1, 0, 1. Fifth LED, and 6th LED. Oh, oops, this is not 6 LED, this is 7 off. 6 LED, yeah, this one 6 LED. So basically, when I connect, when this one are all up, they are all short circuited to the ground, because when they are not connected, they give light and they are straight away connected to VCC. Here, this SIR resistor connected to VCC here. So when it is up, it is connected to VCC straight away. No, VCC here, connect to the SR resistor straight away to the LED, and then this one is determining when it's down, it's short circuited to the ground. Thank you. To present to you Lab 3 Part 2 ADC converter. So our circuit will have a ADC channel connected to a 270 ohm resistor and the potential meter, which is 5 kilo ohm, and then a 3.3 volt power supply, as you can see here. Okay, first I will have 4 functions: initialize ADC, call ADC, do ADC conversion, and delay. In my initialize ADC, I will be using mode 2 for the configure one to have a 10-bit single add, to have a 10-bit single and input, and then I will be using 4 sampling I will use 4 sample as my sampling size. Okay, these are the configurations I use. In calibrate ADC, what I'm doing is I'm going to calibrate the thing. Actually, I don't calibrate the thing, I just declare the ports, and then this part will do the calibrating itself. Okay, in do ADC conversion, since as the question stated, we will need 2 decimal points here. Okay, so we need 2 decimal points, which is here decimal 1 and decimal 2. So what I do is I make the value bigger, then modulus it by 10 to get the decimal value out. Okay, moving on. In the delay function, this is just delay for 1 second. Then in the main function, this one is to make it to use ADC, you must use this clock 6, and then the clock initialize is to be able to use Kitty. Then inside the for loop, I will keep on doing ADC conversion from the given a change in the potential meter, it will constantly give me a value of something from the 3.3 volts and then delay so that you can see. Okay, now I will show you the ADC conversion potential meter. Okay, let me run the program first. Wait a while. Let me run it. Okay, so this is at 0.00 watt. Let me turn this thing now. Now, show the input there. It's constantly changing from 0. Then I will try to increment it as big as possible now. Show there. The maximum it can go should be 3.3 volts. This is the max it can go. Still can go. Okay, 1023 is the limit that it can go. Hello guys, today I'm going to do Lab 3 Part 2. Measure light level from light sensor of FDRM board. Okay, light sensor is on channel 13 on this board here. Okay, so right now I'm going to show you the code. Okay, I have 4 functions again. Initialize ADC, calibrate ADC, do ADC conversion and delay. The initialization, the one thing I only change is that I choose the 11-bit differential mode. Then the calibration is pretty much the same. Do ADC conversion, it's just that this port here I changed to, I'm sorry, it is 19, port 19 is for the light sensor. Okay, then delay function 1 second. Then this one is clock initialize to talk to Kitty, and then this one to use ADC. To use ADC you need clock 6 and then do ADC conversion, then just print that value. Okay, let me show the thing. Let me run this. Yeah, let me build this. Just a moment. Okay, so right now it is printing like that value. Let me try to on this. The value changed to about 50, 60 like that. Then let me increase. Let me go nearer. Okay, it printed out 44 just now. The light sensor is this one. Yeah, it's very tough right now. Yeah, if I straight away put my hand, cover it, then the value will be 900. Basically with no, almost no light on. And then with light on, then it will be very small. So with more light, the value is smaller. Okay, thank you. Hello guys, today we are going to do part 3, which is combining light sensor and the Charlie plexing together. So basically right now, since my light sensor give me value from 0 to 1023 because I set it to be 10-bit single-ended, so I can have 7, since I have 7 different stages, which is 0 LED on, 1, 2, 3, 4, 5, 6 LED on, so I divide them by 7 to get the range of values. So if light sensor is from 0 to 147, which is the brightest range, 0 LEDs will light up, and if light sensor value is from 883 to 1023, the 6 LED will light up, and so on in the middle. Okay, moving to the code. Basically the code is pretty much the same. I have 3 outputs and I will be using light level, which is 2 ADC conversion, but I just call it a different name. Initialize ADC, initialize the Charlie plexing, set which LED you want to on, and delay. So here I declare like this. It's 11-bit differential, but it is 10-bit, but the MSB is used as negative value, I think. Okay, moving on, I initialize the ports. Since I use port A4, 5, 13. Okay, this one is A4, this one is A5, this one is A13. Okay, moving on. I declare them first, then I declare all of them as output. So now this one is basically the same as before. Scrolling down, the only major difference is here. If it is from 0 to 147, it will return to me a value of 0 for no LEDs to light on, and so on. First LED, second, third, fourth, so on, 5th, 6th. Okay, and then I will show the value on the screen also, what level it is, what range, what value the light sensor is giving, and also which LED should be on. Okay, moving on. This one is just initializing. Clock initialize is for Kitty. Initialize Charlie plexing for the ports. Then this one is for using ADC. Okay, let me show you the program, how it runs. Let me run it. Okay, so now I shall show you the program. Now the light is closer to that LED there, to the light sensor, and the value you can see is getting smaller, and the LEDs are descending. And then now lighting it up ascendingly, 3, 4, 5, 6, again, show them again, going down, 6, 5, 4, 3, 2, 1, and no LED. Okay, thank you.